Alright, this is video 1 for lesson 2.6. It talks about, excuse me, um, units, unit rates, conversions, that kind of stuff. So let's start with some vocabulary. These are in your book as well. The first one is a ratio. A ratio compares two numbers by division. Now most of the time we show division as a fraction bar. So 2/3 is actually what we call a ratio. It's comparing two numbers, a 2 and a 3, by division. There are other ways to write a ratio as well. I'm just going to show them to you, but most of the time we will use a fraction as the way to do it. Another way is to, if we were sticking with the same numbers, another way would be to do 2 and then a dot dot 3. That's red, 2 to 3. Or you can literally say 2 and then so the number 2, the word 2, and then 3. That's the third way that we can write ratios. Okay? Just going in with this further, it says you can also think of a ratio as a multiplicative relationship. For example, if the ratio of the number of boys to the number of girls in a class, maybe our class, is 2 to 1, then the number of boys is 2 times the number of girls. Because if for every one girl there's 2 boys, that would mean there's the double amount of them. Okay. Another thing, a ratio that compares quantities measured in different units. So in this example, we were talking about people and people, so it's called a ratio. But if we're comparing things with different units, it would be called a rate. So maybe we're comparing, let's see, the one they give an example of speed. Okay, miles per hour. Okay, you're comparing miles and hours. You're comparing two things. You're using division. Per means to divide, but you're using two different units. And then it says a rate with a denominator of 1 unit is what we call a unit rate. Okay, so it's 1 on the bottom. It's because it's per one thing. Okay, so that's our vocabulary. Now, these are probably things you don't really think to do, possibly when you go to the store, but when I go to the store, I like to know that I'm getting the best deal, and I can figure that out. So it says you're shopping for peanut butter. The costs are listed below. What is the best deal? So 40 ounces cost $4.37, 16 is $2.15, and 28 is $3.23. Okay, so we need to be able to figure it out. Now, not that there's really a right way or a wrong way with this, but most of the time people say cost per amount. So like dollars per ounce. And most people don't say ounces per dollar. That doesn't make as much sense. Now, if you compared it as ounces per dollar, as long as you compared it the exact same way in all three, you'd still be able to figure it out, which is the better deal. But it's best to take the dollars, so my 437, and divide by my 40. And I take my 215 and divide by my 16. And I take my 323 and divide by my 28. And this is a lesson that you'll get to use a calculator on. So 4.37 divided by 40, so that's about, when I round it, about 11 cents per ounce. 215 divided by 16 is about 13 cents per ounce. And $3.23 divided by 28, because remember per means to divide, and that's about 12 cents. So most of the times it is true that the more you buy, the better deal you get. Not necessarily always, but that is the better deal on this one. The next one, it says you are shopping for t-shirts. Which store offers the best deal? So at store A, you can get 2 shirts for $25. Store B, 4 shirts for $45. Store C, 3 shirts for $30. Okay, so same thing, I'm going to calculate this, and most people would try to figure out the cost per shirt, not the shirt per cost or the shirt per dollar. So I'm going to take, so once it is again, the cost per shirt, so I'm going to take my $25 divided by my 2 shirts, and I can do that one in my head. I get $12.50. Alright, this one I'll take my $45 divided by 4. Not as easy to do, but I think we can figure this one out. 4 goes into 4 one time, that's 4. Bring down my 5, goes into that one time. I'd have to add a decimal and a 0, bring down a 0. 4 goes into 10 two times, that's 8. I get a 2, bring down another 0. And 4 goes into 25 times. So it's $11.25. And then this one, I take my $30 divided by my 3 shirts, and I get $10 per shirt. So the 3 shirts for $30 is actually the better deal in this situation. Instead of it being the more shirts you buy, the better deal it is. Okay, so that's just comparing unit rates. Another thing that we can do, it says Bellingham, Washington had an area of 25.4 square miles and a population of 74,547 during 1 year. Bakersfield, California had an area of 113.1 square miles and a population of 295,536 during the same year. Which city had a greater number of people per square mile? You don't even have to think about what order it is in this one because it says it right here. They want to know people per square mile. My people will go on top. My square miles will go on bottom because that's what per means, to divide. People per mile. People divided by miles. So for Washington, I would have my 74,547 divided by 25.4. For Bakersfield, I would have 295,536 divided by 113.1. Type that into our calculator. 74,547 divided by 25.1. That is equal to 2, and I'm going to round up, so 2,935. And then I'm going to put a label on here, that's people per square mile. And on the bottom one, 295,536 divided by 113.1. And I get 2,613 people per square mile. And it wants to know which city had the greater number, so that would mean my answer for this problem would be Bakersfield. Alright, the next thing, the only other thing we need to talk about in this video is using conversion factors. You've probably used it some in Ms. Bergstrom's, maybe in a little bit different of a way, but I use, I think, what they call a skeleton model. So it says to convert from one unit to another, such as feet to inches, you multiply the original unit by a conversion factor that produces the desired unit. A conversion factor is basically just a ratio of two equivalent measures in different units. A conversion factor is always equal to 1. It won't look like it's equal to 1, but it will be equal to 1. Such as right here, 1 foot, it has 1 foot over 12 inches. Now it doesn't look like 1 by looking at it, but there are 12 inches in 1 foot. It is equal to that. There are some other ones it says on page 723 to kind of help you out with that. Okay, so let's practice a few of these. The first one, 330 minutes, 2 hours. The first thing you always do is write down your original problem. Make sure you include the unit. Always, always, always include the unit, because that guides you with your conversion factor. This is one of the very few times you can actually use a X for your multiplication. If you'd rather use a dot, I'm fine with that. This is kind of how I do it though. Now, really the only thing you have to figure out is what units and what values go where. Technically, this would be on the top. So in order to cancel things out, when I'm multiplying, I can't cancel straight across this way, but I can cancel crosswise and crosswise. So I need to put my minutes down here. Whatever you need to cancel, or basically whatever unit you start with, that goes on the bottom. Whatever unit you're trying to go to, that goes on the top. So my hours would be on top, my minutes would be on bottom. Now I just got to figure out the relationship. Okay, what do I know about how hours and minutes compare? Well, I know that 1 hour is the same as 60 minutes. So now I can type that into my calculator. And I'm basically, I'll rewrite it, I'm multiplying straight across, so I'll get 330 divided by 60, because that times that is just 330, and that times that is just 60, and remember our division sign, our fraction bar means to divide, and 330 divided by 60 is 5.5 hours. Let's look at another one. 15 kilograms to grams. Always start with the first one that you're given, 15 kilograms. In my conversion factor, my kilograms is what I start with, so that goes on the bottom. My grams is what I'm going to, so that goes on the top. Kilo means 1,000, so in 1 kilogram, there are 1,000 grams. I'm going to put that over 1 to see what I'm doing. In this situation, all I have to do is multiply my top and top, because if I divide by 1, it doesn't change it. And multiplying by 1,000 just moves the decimal 3 spots, so it is 15,000 grams in 1 kilogram. Couple more to look at. The next one, what is 1,250 centimeters converted to meters? Always start with what you're given. 1250, making sure we include the unit. Centimeters is what I have started with there, so that goes on the bottom. Meters is what I'm going to, that goes on the top. Well, I know that in 1 meter, centa means 100, so there's 100 centimeters in 1 meter. Multiply straight across, 1250 divided by 100. Dividing by 100 just moves my decimal 2 spots to the left. Multiplying would move it to the right, dividing moves it to the left. So it'd go 1, 2, and it'd be 12.50, or just 12.5 meters. One last problem to make sure it's making good sense. So I have 168 hours, and I'm converting it to days. Always start with what you're given. Hours is the unit I'm giving, so that will go on the bottom over here. Days will go on top. And I know that in 1 day, there are 24 hours. So when I go straight across, I would have 168 divided by 24. And when I do that math on my calculator, I get that 168 hours would equal 7 days. Biggest thing you need to remember is to write down what you're given first. Include the unit, because that unit has to be on the bottom so that it cancels. Then you fill in the unit you're trying to go to on the top. Make sure that even though they're in different units, that the top number and the bottom number are actually equal.